In this video, we are going to discuss the quantum numbers and their importance. So we have four quantum numbers. We begin with the principal quantum number, which is n. So we start with the principal quantum number, or n. It takes the symbol n. So n is the principal quantum number. Then we have L, which is the subsidiary quantum number. And we have ML, which is the magnetic quantum number. And we have something like MS, or it's called MS, the spin quantum number. So these are the four quantum numbers. I will discuss each quantum number in detail. So we start with the principal quantum number. The principal quantum number, or n, it describes the main energy levels, or the outermost shells in the atom. You have studied before the main energy levels such as K, L, M, N, O, P, and Q. So you have 7 energy levels, and each energy level is represented by the principal quantum number. So K takes N is equal to 1, L, N is equal to 2, M, N is equal to 3, N is equal to 4, O, N is equal to 5, and P, or P, N is equal to 6, and Q, N is equal to 7. So each energy level is represented by the principal quantum number, and each principal quantum number has a specific principal quantum number, as we can see here. A good notice here that you only see that these quantum numbers, or principal quantum numbers, are integer numbers, right? So they always take an integer number, like 1, 2, 3, 4, not a decimal, like 0 0.5, 0 0.6, or 0 0.7. It has to be an integer. So that's it for the principal quantum number. Now let's discuss the subsidiary quantum number, which is L, lowercase l. So L is the subsidiary quantum number. The subsidiary quantum number describes the shape of the electron cloud. So it describes the shape of the electron cloud. And it also describes the sublevel. In order to find how many sublevels in the main energy level, you can calculate it by the relation L, which is the subsidiary quantum number, is equal to 0 to n minus 1. So let's try when we talk about n is equal to 2, or the second energy level. So L in this case should be 0 to 2 minus 1, which is 0 to 1. Then L is 0 and 1, right? So you have two sublevels here, which is sublevel 0, which is S, and sublevel 1, which is P. So let's try it when you are in the first energy level. So L is equal to 0 to n minus 1. So you have 0 to 1 minus 1, um, which is equal to 0 to 0. This means 0. So you have only s orbital, s type orbital, or s sublevel, I should say. So what if you are in the um, what if you are in the third energy level, or let's say fourth energy level, better. So let's say if you, when n is equal to 4, then L is equal to 0 to n minus 1. So L is equal to 0 to 4 minus 1. That means 0 till 3. That means you have 0, 1, 2, and 3. You have 4 sublevels, right? So the when the L value is equal to 0, that means when the L value is equal to 0, that means you have an S sublevel. And when you have L is equal to 1, that means you have a P sublevel. What if you have an L, or a subsidiary quantum number, which is equal to 2? That means you have a D sublevel. And when you have an L, or a subsidiary quantum number, which is equal to 3, you have an F sublevel. So in the fourth energy level, you have 4 sublevels: S, P, D, and F. In the first, you have only S. In the second, you have 2 S and P sublevels. I hope it's clear for you now. Now we move on to the magnetic quantum number, ML, or the magnetic quantum number. So ML values is equal to negative L, 0 till positive L. So let's find out how can we calculate something like this. So when L is equal to 0, then ML should be negative 0 to 0 till positive 0. That means you have 0, right? So ML should be 0, right? So what if you have an L which is equal to 1? So ML value should be equal to negative 1 till positive 1, right? So ML values should range from negative 1, 0, and positive 1. And when you have, and this is, and this makes sense because you have L, right? Or you have the subsidiary quantum number, which is equal to 1. That means you have a P sublevel. So when you have P sublevel, you have 3 orbitals, right? Which is negative 1, 0, and positive 1. What if you have um, what if you have a subsidiary quantum number which is equal to 2? That means ML should range from negative 2 till positive 2, right? So the ML values, the ML values sh should be negative 2, negative 1, 0, positive 1, and positive 2. Each magnetic quantum number represents an orbital. So when you are, or when you have a subsidiary quantum number which is equal to 2, that means you have a D sublevel. So in the D sublevel, you have 5 orbitals. So 1, 2, 3, 4, 5. So you have -2 orbital, -1 orbital, 0 orbital, +1 orbital, and +2. So as you can see here, the magnetic quantum number refers to the orientation of the sublevel, or it describes the shape or the orientation of the orbitals. So for example, here in the sublevel P, which is the subsidiary quantum number is equal to 1 here, you have um, you have 3 types of orbitals. We can name them as px, py, and pz according to their orientation in the 3 dimensions. And the shapes, let me draw the shapes of the p orbitals. So you have the px, which is found on the x-axis, and you have the py, like here, and you have the pz. I should first draw the z-axis. That's like z-axis. So you have here your y-axis, x-axis, and z-axis. So now you understand that the magnetic magnetic quantum number describes the orientation of the orbitals in the 3 dimensions. Then we have the spin quantum number, which is ms. ms, which is the spin quantum number. So the values for ms are either +1/2 or -1/2. What does it mean then? A +1/2, that means the spin of the electron around its axis, which is clockwise, it means that the spin of the electron is clockwise around its axis. So it's like, let's draw it like this. It spins around its axis clockwise. And when you have the orientation or the spin, sorry, I should say the spin of the electron anti-clockwise, then you have the ms value is equal to -1/2. So the spin of the electron is anti-clockwise. If you enjoyed the video, please like, subscribe, and share the video.